Okay, so we have seen, and I think by now we really do appreciate the need for thermoregulation. So let's now see how these guys do their thing. How we really do maintain the internal body temperature constant. The core body temperature. The core temperature constant. Now, like I told you, our bodies have a reference point. A reference point. Okay? It has a reference point. The normal body temperature in this case. And this reference point is maintained within the hypothalamus. It is this hypothalamus that has that reference point, that critical point, over which body temperature is going to be set to. If it goes high, then the hypothalamus is going to know that, oh, it has gone higher than what we need. Similarly, when it goes below, it will know that, yeah, it's below the reference point. And usually, this reference point, okay, this reference point, it is the actual optimum temperature that is needed by our enzymes and other body physiological activities to occur at their best. Unless otherwise. Like for instance, when pathogens invade you, the reference point is changed so that the body temperature is elevated. We shall see how and why. Okay? Now, in the case of any deviation from the norm, now that's the stimulus. And I think I told you how to answer such questions. You are always given a norm, and then the stimulus must be there. Okay? The stimulus must be there. And in this case, the stimulus is any deviation from the norm, and let's begin with a positive deviation. That is if the temperature goes above normal. Maybe somebody is involved in a state of physical activity, somebody is physically active, maybe it's the weather, it's really hot, maybe in any way, the temperature goes above normal. Now, if temperature goes above normal, then blood that is flowing through the hypothalamus is going to flow at a temperature that is above the normal level, the reference point. Okay? And therefore, depending if it is environmental or if it is something to do with the environment, then the hot thermoreceptors, like I told you, we saw the structure, okay, of the skin. We studied the internal structure of the skin. So within the skin, we saw that we have there, within the dermis, we saw that we have there receptors, and one of them is the thermoreceptors. And still, the thermoreceptors, they are divided into two classes: the hot thermoreceptors and the cold thermoreceptors. Now, the hot thermoreceptors, they are the ones that actually detect that is temperature is above. This is too much heat. Okay? Remember, temperature is the measure, the degree of measurement of heat. You cannot quantify heat, maybe apart from joules. But we can easily quantify heat in the form of temperature, and we use a thermometer to measure heat. So the hot thermoreceptors will detect, and if it is internal, then the blood that is flowing through the hypothalamus is going to be at relatively higher temperature than the norm. So the thermoreceptors in the skin and in the hypothalamus they will be stimulated. Okay? And if they are stimulated, then they will send impulses to the respective organs. Okay? And actually, the hypothalamus, actually, when these receptors are stimulated, they will send impulses to the heat loss center. Okay? Now, the hypothalamus is divided into two. You have the heat loss center, depending, actually, if you are dealing with heat, then we have the heat loss center, okay, and the heat gain center of the hypothalamus. So depending on the need, if temperature is too much, if heat is too much in the body, then the heat loss center is the one that will be stimulated. And now if this center is stimulated, then it will send the impulse through the efferent vessels, efferent nerves, not vessels, to the respective effector organs, so that different physiological changes will occur to bring back the temperatures to the normal levels. Okay? To bring back temperature to the normal level. And so this is a typical example of a negative deviation. Somebody was asking me what the negative deviation is, and we discussed this, where there is a norm and then a disturbance from the norm, and then the body responds to bring about certain physiological changes that will bring back a disturbance, that will restore back the norm. And so that's why it is called a negative deviation. So the same applies to this. There is a deviation and it's a positive deviation. Then the hot thermoreceptors will detect, and then the heat loss center within the hypothalamus will be stimulated, and then it will send an impulse to the respective effector organs, so that you lose a lot of heat from your body and temperature is restored back to the norm. So now, what are some of the responses that will be given by these different receptors? Number one, we have the sweat glands. Now we saw the sweat glands. Now these sweat glands, when they are stimulated, they will produce a lot of sweat. Okay? You know, they are connected to the outside surface of the skin through a sweat duct and then a pore. So this is a typical example of an exocrine gland, a duct gland. You can see it has a duct. Now these sweat glands, when they are stimulated, they will absorb the heat, okay? And then when they absorb the heat, they will convert the heat energy, or they will use that heat energy to vaporize the water molecules, to vaporize water within the sweat glands. And when this water is vaporized, then it will evaporate out of these sweat glands through the sweat duct, through the sweat pore to the outside environment. And when it reaches here, okay, it will find when this outside environment is relatively colder than the internal, so it will condense, and the other heat that was used to vaporize the water to form sweat is given out. Okay? And then the sweat condenses on the skin as sweat. That's why when you start to exercise, you are right now, you are okay, you are kawa, the skin is dry, you are smiling, you are shining, everything is good. But the moment you start to exercise, 100 meters, that's 100 meters, 200, 400, 1000 meters. Oh, all of you will be too wet. Why? Because of this sweat. Now, as you are sweating, you are losing the latent heat of vaporization. That is the enthalpy change that occurs, or the heat required to vaporize water, or heat that is given out when water vapor condenses into water. And so by doing that, you'll be able to cool down your body. Then another mechanism is we have the Erector Pirimasu. We saw the Erector Pirimasu when we were studying the structure of the skin. If this is the hair capsule and this is the hair, okay, and it connects to the outside environment, then this hair capsule is connected to a muscle. I think it's a smooth muscle. You can fact check that. And this muscle is connected just here on the dummy papillae, just here. Now it is this muscle that is known as the erector or erector pili, or you can say pili muscle. Now, before we talk about this, there is one concept I want you to grasp. It will help you even in locomotion, in muscle contraction and stuff like that. When a muscle contracts, okay, it shortens and becomes stiff. This concept is good. When a muscle contracts, it shortens and it becomes stiff. But when a muscle relaxes, it elongates or it lengthens and it slackens, or it elongates and it slackens, I think. Let me use that word.
Excuse me,
Yes.
what happens when it contracts? I
Pardon?
don't know whether it is because of my network or breaching.
The, yeah, it's okay, I get you. I said that if a muscle contracts, it shortens, it becomes short and stiff. You can try it with your biceps and triceps. If you fold your arm, the biceps muscle, the one on top, it becomes stiff and short. But the triceps, the one down, it elongates and slackens. But when you straighten your arm, try to touch the biceps, the muscle up, it elongates and it slackens, but the muscle down, it contracts and it shortens. You can try it right now. Now that concept is going to help you to explain all things concerning muscles. And you know muscles are antagonistic. When this one contracts, automatically this one must relax. And when this one relaxes, automatically the other one. But here we have no antagonistic muscles. But I just wanted to emphasize that. So here we have the erector pirimasu. Now, it is hot. Okay? And when it's hot, the skin hair, they must fall. They shouldn't be raised. Now, remember if it is attached on this hair capsule, this one. If this one shortens, remember this side where it is attached must be stiff. If this one shortens, what is going to happen to this hair? It is going to be pulled to stand, to remain erect. But when it elongates and it slackens, this hair is going to fall down. It is going to slip. It is going to fall. And you lose enough heat. So therefore, the erector pirimasu is going to relax, okay? So that the other tension that was created on the hair follicle, this, I think, yeah, it's a hair follicle, not cap. anyway, okay, hair follicle is removed and the hair falls down. And when the hair is not falls down, sorry, when the hair falls down, then no no layer of moist air is trapped. And if there is no layer of moist air trapped, then you easily lose heat out of your body. Then the metabolic rate reduces due to inhibition of secretion of thyroxine and adrenaline hormone. If you remember from our coordination, we saw that these guys, the thyroxine and adrenaline hormone, they have an effect on the metabolic rate, on the body's metabolism. So therefore, since metabolism, for example, respiration, leads to production of heat, and in this case it's too hot, you don't need the heat. So therefore, what happens? You will inhibit these two hormones, the adrenaline and thyroxine hormone, so that the rate of metabolism reduces, decreases. And so little or no heat is produced internally. Hence, you're not replacing the heat that you are losing. Hence, the body is gonna cool down and everything becomes okay. And you know that we saw that the dermis, we have there a dense network of blood capillaries. In the dermis, you saw that. And the epidermis, not vascularized, not innervated, no nothing. It is just a band of cells. So now these arterioles, together with arteries, okay, arterioles, together with capillaries, that's what I wanted to say. They undergo what we call vasodilation. Okay? And the shunt vessel, now this is the shunt vessel. This blood capillary, this vessel that bypasses, that makes blood to bypass these capillaries. So now, because you want to lose more heat, then the shunt vessel is going to contract and reduces its volume. And then the arterioles, together with capillaries, they undergo vasodilation. They increase in diameter so that large volumes of blood will flow underneath the skin. So that the diffusion distance between the blood that is flowing through these capillaries and the external environment is very small. Hence losing much heat, much more heat, okay, to the surrounding. But we are going to see that in cold, when it's cold, we are going to see what happens. Is it the same thing or it should be different things? That's why you guys, when it's too hot, usually all your blood capillaries are visible under the skin. But when it's too cold, you cannot see any. Okay? You cannot see any, basing on the need at that particular moment. And finally, there is no shivering. I've never seen anybody shiver or anybody shivering in a broad daylight when the sun is really too much. Okay? And you should ask yourself why shivering. And I'll say, yeah, you're going to see the effect of shivering in temperature regulation during cold. So in case there are queries, guys, please feel free to ask.